Hello guys, you're welcome back to my channel. Here we have been asked to determine the number of unpaired electrons in this particular species with electronic configuration of 1s2, 2s2, 2p6, 3s2, and lastly 3p4. Alright, so how are we going to do this? So basically we are going to rewrite this sub-level notation into orbital notation so that we have a visualized picture of the electrons. All right, okay, now if we consider one s2, all right, so an s orbital can only accommodate 2 electrons, right? The total number of electrons in an orbital is limited to 2. That's the maximum number of electrons can be accommodated in an orbital. All right. So here, these electrons are allocated in this fashion, right? One goes in the clockwise direction, while the other goes in the anti-clockwise direction. They don't have to go. They don't have to spin in the same direction. Hope you know that. All right. The second one, we have 2s2 still in the s sub level. Okay, similarly, if one goes clockwise direction, the other will go anti-clockwise direction. Now we have p orbital. Don't forget that our p orbital is threefold degenerate, meaning that we have three subatomic orbitals there. All right, so how are we going to do this? So whenever we are filling electrons into a degenerate orbital, what we normally do is that we have to fill those electrons singly, one by one first, right? This is what we call Hund's rule. Okay, Hund's rule of maximum multiplicity. Now, but out of the 6 we filled 3, right? So we start pairing. Okay, you pair it up and you pair it up like this. How many electrons are here? 6. If you count the number of electrons that we fill so far, we have 10 electrons being consumed already. All right, out of this we still left behind with 6. Okay. And the next one is the 3s2, right? We are now in the third energy level. Our s orbital will still accommodate 2 electrons at maximum. All right. So, and lastly, we have our 3p4 electrons here. Okay. So our p orbital is threefold degenerate. So we have 3 suborbitals in there. Okay, now following Hund's rule, we are going to fill those orbitals one by one first. We have to fill it singly, and after that we now start pairing up the electrons. Okay, now before we fill in 3, all right, so what remains? 1. So that one, you can put the 1 here, you can put it here, you can put it here. So the choice is yours, because these orbitals here, they are degenerate orbitals because they all possess the same energy. So no one is superior than the other. That's what it means. All right. Now, if you look at all this configuration, what can you see? You see that this one is paired up, this one is paired up, all these are paired up. This one too is paired, this one is paired. And how many of these orbitals are not paired? These and these, making 2, right? So the number of unpaired, so the number of unpaired electron, unpaired electron is equal to what? 1 plus 1, which is 2. So we have 2 unpaired electron in this particular chemical species. Please share this up, like and comment. Okay, and don't forget to hit the subscribe button. Thank you very much.